All right, here's the problem we're going to start with today. Okay? F of x, you're given this information. Okay? F of x equals 3x to the 1/3 power. G of x equals the cube root of x. And then later on, we'll use the x equals 27. Okay? But for now, we have f of x and g of x. If I gave you this information, would you know how to find, whoops, don't look at that part. Would you know how to find f plus g of x? How would you go about doing that? What is it asking you to do? Does anybody know what this sign means right here? Add. Okay, add. All right, good. Whew. Scared me for a second. Yes, we're going to add the two equations together. Except before we do that, we're going to make sure that the equations make sense to add together. Okay? Because if I'm going to go and add these two equations right here, my brain's not working really well right now because they don't really look like each other and I don't want to mess with it. Except they really are like each other, aren't they? They're just not written out the way I like to see them. How could I write this one in a different way? I could write it as x to the 1/3, couldn't I? Because remember, this is the power, is 1, and it's really a to the m over n, where m is the power and n is the root. Isn't this the same as x to the 1/3 power? Okay, so now does that make more sense if I add these two together? Now, we know it's the same thing to begin with, right? But sometimes our brains mess with us a little bit. They're like, done, stopping. Because they don't look alike. Well, we made them look alike, and now we're okay. We have 3x to the 1/3 plus x to the 1/3. What is that? That's close. What if it said 3x plus 1x? What would we get? Would we get 4x squared, or we just get 4x? Because I'm adding my x's together. Now I would just get 4x, right? Do I add my exponents when I'm adding my bases? No, we don't, right? We just leave those alone. Okay? So now we have added our two functions, right? So now this is when this x equals 27 comes into play. Because the directions might say, evaluate your new function at x equals 27. Well, what does that mean? Plug it in, right? Evaluate means we're going to substitute something in. So 4 times 27 to the 1/3 power. What should we do first? Should we multiply 4 and 27 first? Oh, no, we cannot do that. Order of operation, police are on their way if you start to do that. Okay? We know we got to do exponents first, right? What's the cube root of 27? Remember, because 27 to the 1/3 power, that's the root. It's the cube root. It's 3, right? So what's 3 times 4? Done. So one more thing before we go on. I've got to know the domain of this new function right here. So thinking for just a second, if the parent function looks like that, because it's a third, right? An x to the 1/3. Now I've got 4x to the 1/3. I know it's going to be this one's going to be a lot steeper, but it's still going to look like that, right? So it's my domain. All real numbers. Done, and go on. You okay with that? Okay. So what are we going to do next, you think? Perfect. F minus g of x. 3x to the 1/3 minus x to the 1/3. What do you think that is? 2x to the 1/3. Very good. Because it told you to? Yeah. It's okay. So, what do we want to do now? Let's evaluate it at 27. So I have 2 times 27 to the 1/3 power. 27 to the 1/3 power is 3 times 2. Done. What's our domain of this function right here? How's it going to look compared to this dark purple line right here and the parent function right there? Shallower than the dark one, but steeper than the dotted one. That's perfect. Okay? Does that change the domain from what it was when there was a 4? Nope. It's still all real numbers, isn't it? Okay. Let's scoot it up a little bit. Fg of x. What's it asking me to do? Multiply 3x to the 1/3 times x to the 1/3. I'm multiplying. If I multiply the constants, I just get a 3. What do I do with my exponents when I'm multiplying like bases? Add. What do I get? 2/3. Let's change it up and do our domain first, because that's how we roll. Oh, geez. I know what 1/3 looks like. Do I know what something to the 2/3 looks like? Because I added my exponents. When I'm multiplying like bases, I add my exponents. 1/3 and 1/3 is 2/3. Okay, good question. Do you guys know what x to the 2/3 looks like? I mean, I know because I've done this problem already today, but I couldn't think of how it looked like this morning, so guess what I did? Yeah, I put it in the calculator, right? Somebody have theirs up real quick? Can I see it? Let me see it real fast. I mean, don't run because you'll trip, but I'm not saying you're accident prone, but I don't really have to say it. Okay, so there's what it looks like. 3x to the 2/3. So real quick, I'm going to go ahead and just put in x to the 2/3 so we can see what that looks like. Don't leave. So we have something to compare it to. So here, this original one, the red one is the original one, x to the 2/3, and then this is 3x to the 2/3. But we already knew that because we know that a multiplier in the front stretches it vertically, right? We knew it would look like that. Of course we did. Okay? But it's kind of like a curvish, V-ish shape-ish. It's a domain of that. The domain is still all real numbers, isn't it? Okay? Now, let's evaluate it. 3 times 27 to the 2/3 power. What's the cube root of 27? Remember, the bottom's the root, so I took the cube root of 27 and we got 3. And then what do I do now? Good. 3 squared. What is 3 squared? 9 times 3? 27. Now, it's not always like that, just for the record. It just happened to work out like that on this problem. It's not always going to be the number we started with. Okay? Any questions about that? You getting the general idea? Okay, what's the last one we're going to do then? F over g of x equals 3x to the 1/3 over x to the 1/3. So first question is, what do I do with my exponents when I'm dividing like bases? I subtract, right? So what's 1/3 minus 1/3? 0. What's x to the 0 power? 1. Anything to the 0 power is always 1, right? So what's 1 times 3? Now, the other thing that you can think of is that anything divided by itself is just 1, so that's a 1. What's left? 3. 1 times 3. Okay? So first of all, let's talk about the domain. If you'll remember, this is saying y equals 3. That looks like this. Right? Pretend that line is straight. You guys are good at that. Okay? What's the domain of that line? All real numbers? Ugh. It looks like all real numbers, doesn't it? But we have to use our brain. Okay? I'm not saying you're wrong, because I'm going to go ahead and write all real numbers, but what kind of a problem is this? It's a division problem, isn't it? And what are we not allowed to divide by ever? Only Chuck Norris is allowed to divide by 0. Yeah. Okay? We're not allowed to divide by 0. What would make this problem, what x value would make me dividing by 0? In this particular case, if x was 0, right? So the domain of this problem is all real numbers except 0. Okay? Not because it's a line, because we know that the domain of a line is all real numbers. The problem comes because I'm dividing right here. And if x is 0, that means I'm dividing by 0, and I cannot do that. Okay? Does that make sense? That's a little different than all these other ones up here that we did. Okay? If I'm dividing by 0, that's a problem. Okay? So is everybody okay with that? Are we ready to go on and evaluate, or you have questions still? Good? Okay, so let's evaluate this. Okay, good. 3, done. Right? There's no variable to put x equals 27 in for, so it's just what I got as my answer is 3. Okay? Any questions about this? Now, domains are going to change when it's not something to the 1/3 power, right? What if it was something to the 1/2 power? What's that look like? That looks like that. What's the domain of this? Yep, all numbers greater than 0. X is greater than 0. Okay? So some of these you're going to have to just pay attention to when it asks for the domain. What's the root? Well, even roots are going to look similar to this, and they're going to have a starting point. Okay? Odd roots, like a 3 or a 5 or something like that, those are going to look more like the S's that we looked up here, weird S's that we looked up here, and it's going to be all real numbers. Okay? Any questions? So the caution that I have for you as you start your homework is to just be careful about reading the directions. Okay? The first couple, all it wants you to do is add and subtract. The second couple, all it wants you to do is multiply and divide. The third couple, it wants you to add, subtract, multiply, and divide, but it wants you to do all of it in your calculator. Use the graph on your calculator, because all you're going to do is put it in and then tell what the domain and range is based on what the graph is that's given to you in your calculator. Okay? There's no like mathy stuff you have to do. Write this down. Write it down like this, but then draw me a sketch. There's nothing to equal it here. Okay? Draw me a sketch like this and be able to tell me what the domain and range is. Okay? So just please read the directions and follow them. Okay? Any questions? All right, I'd like to give you the rest of the period to work on your homework if that's okay with you.